At GCSE, you probably learnt a circuit diagram like this to find the IV characteristics of a component, in this case a resistor, where you could adjust the resistance of a variable resistor to get your different currents and potential differences. But unfortunately, when you put the variable resistor onto its maximum resistance, you still get quite a large potential difference across the resistor, so it isn't a very good circuit. Using this circuit with a potentiometer is much better because we can go right from the potential difference of the power supply all the way down to zero in small steps as we slide the sliding contact on the potentiometer. So this is a much better circuit as we can get the full range of currents and potential differences. Let's understand a bit more about how this works by taking a look at the rheostat, which is a potentiometer designed to take a large current. It has three connections. The two at the bottom are connected on either end of this coil of resistance wire, and then we have a top connection which is connected to this sliding contact which can be moved to any position. If you use either of the bottom connections and the top one, then you'll have a variable resistor, which you can change its resistance depending on the position of the sliding contact. If you want to use it as a potentiometer, then you need to connect the two bottom connections directly to the power supply, and then your top connection will give you a variable potential difference depending on the slider's position. You now have a complete circuit that goes from the power supply and round all the way around the coil of resistance wire and back to the power supply, and current will flow that way the whole time. With the sliding contact at the right hand end, you'll effectively be connecting directly to the full potential difference of the power supply, and so that's what you'll get for the circuit with the ammeter and resistor in it. With the sliding contact at the left-hand end, you will effectively have both ends of the part of the circuit with the ammeter and the resistor connected to the negative terminal of the power supply, so there will be no potential difference connected across it. But with the sliding contact somewhere in the middle of the rheostat, you will have effectively created a potential divider with one resistor to the right of the sliding contact and another to the left of the sliding contact, and the potential difference that you get out will depend on the proportion of the total resistance that you've got to the left. And therefore, as you slide the contact from right to left, you go from the maximum potential difference of the power supply going to your branch with the ammeter and resistor in it, down to zero potential difference depending on the exact position of the slider. This allows you to get a full range of potential differences and currents, which will give you a good IV graph for your component, which doesn't just have to be a resistor. It could be a filament lamp or an LED or a diode. And this is the circuit that you'd be expected to draw in an A-level exam if you're doing the IV characteristics of a component. The problem with using the rheostat simply as a variable resistor is that when you put it to its maximum resistance, you've got a potential divider of the maximum resistance of the rheostat and your component. And unless the maximum resistance of the rheostat is very large compared to your component, you won't get the lowest potential differences across your component. So that's why this isn't really a very good circuit, but is adequate to be taught at GCSE level.